Okay, so we're going to take a look at some of the problems from the new homework system. So, we're going to take a look at one of the ones in which it features a dog pulling on a pillow. Now this one should be, hopefully, a relatively straightforward vectors problem. Now, why I wanted to include this is force is a vector. So what we need is a fine canine friend, and the dog, whatever type it may be, is pulling on a pillow. Pillow. Very extremely poorly drawn. Now, the dog is pulling on a pillow with a force of 8 newtons at an angle of 36.9 degrees above the horizontal. I probably should have drawn this maybe a little differently. Let's see if I can... flip. Left, right. There we go. The reason why is, it is pulling with a force that they say is up like this. It is 8 newtons at 36.9 degrees. I have a tendency of drawing things from the left moving towards the right, but without having to go into too much detail, you can have it point the other way. We usually have that the positive x direction is to the right and the positive y direction is up. We could have easily done it the other way. It's asking for a few things though. It's asking for the x and y components. So we need to split this up. We've got a force of 8 newtons that is directed up at 36.9 degrees. Now we could have pointed it pretty much any of the ways in here, but this is how we usually draw it, and what we're looking for is just the value of the x and the y component. Now this is it in two directions. What we want is the x component, fx, and the y component, fy. Now this is a vector problem. We're simply splitting up this vector, 8 newtons, it's a force, and we're going to split it up into its x and y components. Alright, well we'll use our trigonometric relationships. This is a triangle, so we're going to apply SO, CA, TOA. If I want to find my x component, it is the adjacent one. It's right next to the angle that I know. So that would be CA. So we're going to do cosine of 36.9 degrees equals my adjacent, A, my x component, over my hypotenuse, H, which is 8 newtons. I want to solve for my x component, so I multiply both sides by 8 newtons. And I find that my x component is equal to 8 newtons times cosine of 36.9 degrees. Now, remember, this is degrees, not radians, so make certain your calculator is set to degrees. I do not know how to change it on all of them, but on most TI models, up here there's a button called Mode, and then it'll bring up some options. Partway down you'll see degree or radian. You can navigate to that and select degree, and then second, mode will get you back out of it. In this case, mine should be set to degrees, not radians. And so when I solve this, I end up with my x component is going to be equal to 6.40 newtons. Alright. I can do the same thing with the y component, which I believe is part 2. I would use SO in that case, because now I'm going to be dealing with the opposite side. So that tells me that sine of 36.9 degrees equals Fy, my opposite side, over 8 newtons. I want to solve for Fy, so I'm going to multiply both sides by 8 newtons. And I'm going to end up with Fy is going to be equal to about 4.80 newtons. Important things to remember. The stuff we learned in vectors come back into this. We're going to see in class that there are going to be some forces that we will need to split into their x and y components. Some of them, the way we set up the problem, they're already in x and y components, but some of them we're going to have to split up manually. This is a reminder of how to work with vectors, and that force, one of our new ideas, is very much a vector.